We're looking at the reactance of capacitors and inductors. So reactance is the opposition presented to alternating current by an inductor or capacitor. So it's similar to resistance in that it reduces current, but it does not lose heat like a reactor would. It's measured in ohms like resistance, so it's very similar, but just differs in a few ways. So it's used in calculations when you're calculating the total resistance of a circuit. So we use inductive and capacitive reactance along with resistance to find impedance, which is the total resistance of a circuit. And that's denoted by Z, which is our value there. So if we're looking at inductive reactance, it's directly proportional to frequency in the inductance. So if those two values increase, so will our inductive reactance. In an ideal circuit, if we were to add an ideal inductor, it would cause the current to lag. So our angular frequency would change. Capacitive reactance is inversely proportional. So if we were to increase capacitance or frequency, our capacitive reactance will actually decrease. So they work opposite. In an ideal AC circuit, if we have a capacitor, the current will lead the voltage, so it does the opposite. Excuse me. It does the opposite, so it will phase shift to the right instead when we're talking about our frequency, angular frequency. So I just have two calculations here just to show you simply how it works. So we're going to look at our first one, which is just calculating capacitive reactance. So if we have 1.9 microfarads as our value, it's subjected to a voltage and our frequency is 105 hertz. So as you can see, we've just got our values there. I've just converted that from microfarads to farads to make sure we're all working in the same units. And then I'm just going to use the formula from before. So I'm going to go 1 over 2 pi times our capacitance times our frequency, and we get a value of 1205 ohms. Or if we convert that to kilo ohms, we get 1.206 kilo ohms. And our next one, we're using an inductor instead, but instead we're going to work backwards from our reactance to find a frequency. So as you can see, we have a 420 millihenry inductor, and we have 5.4 kilo ohms of reactance. So as you can see, I've just converted those into our standard form, changed them and put them into our formula. Our formula is just a flipped version of our previous reactance formula. I've just changed things around to make F the subject, which is easy to do because it's a direct relationship. So I've just gone 5400 divided by 2 pi times our inductance, which gives us a value of 2046 hertz, which will convert to 2.046 kilohertz. Thank you for watching.